Hello everyone, welcome back to Comp 208. I have received some questions from some students concerning the if structure. So what I will do now is that I will give you a review of all the structures that you could see of if. So the different ways that you can see if in C language and in other languages. So we're going to see it in C language, the different ways that you could see if, all the different ways. We have if statement, if else statement, nested if else, and if else ladder. I'm going to talk about them all, okay, before we start with a new topic with a repetition structure. So in this example, I'll start with an example. This is going to be only if. So can we have an if without an else? Yes, we can. So this is only if. I will explain it by this program to display only numbers that are negative. So if a number is negative, it will be displayed. If it's not negative, if it's positive, it will do nothing. So it's an if only. So let's look at the program here. We enter a number, okay, using scanf. You should be familiar with scanf by now. So if number less than 0, this is an if condition. So if, this is the if statement, if condition, let me use a pen. So if followed by the condition, this condition, as I said before, is a yes or no question. So the answer is either yes, which is true, or no, which is false. So if number is less than 0, if it's true, I will execute the body of f. Where is the body of f? It's enclosed between these two braces. So this is the body of f. This body of f is going to be executed only if this condition was true. So if the condition is true, this body will be executed. If it's false, if the number was positive, it will not do the body. It will continue after the body, whatever is at this point. This is very important. It's a common mistake among students. You should know that if the if was false, you just don't do the if condition was false. You just skip the body of if only the body of if, and you continue with whatever statements you have in your program. So if, as you can see, no semicolon, you start with a brace and you close the body of the if with another brace. We'll see later that these braces are optional if the body of if is a single line. So if the body of if is a single line, I can remove the braces. But now I keep them so that you can see where the body of if starts and where it ends. So if it's negative, this is going to be executed, which is what? You entered this number, okay? When the if body finishes, you continue what? Whatever statements you have after that. What do we have here? The if statement is easy. So let's see two outputs here. Enter an integer. Let's say you entered -2. Okay, so you entered scanf -2. We're here now. Okay, is number less than 0? Yes, so you execute the body. You say you entered -2 because the body is executed because -2 is negative. What do you do after the body of if? You execute whatever statements there are under it, okay? So the if statement is easy, is output. Now, if the user entered 5, so 5 is not negative. So if number less than 0 is 5 less than 0, so 5 is not less than 0. So you don't do the body. You skip the body of if, but you continue the statement after if. This is very important to know. So you continue the statement after if, which is what the if statement is easy. So what did we have in the second output when the input was positive? You just skip the body of if. So if the condition is false, you skip the body of if, you continue whatever is in your program. This is very essential to understand and very straightforward. Now, you could have, as we said in this example, we just said, only if statement. There is no else. There was no else for this if. Or you can have an if with an else. So again, I am reviewing what we talked about last week. So if with an else. In this case, if has a body enclosed between two braces. This is the body of if. These are the statements that will execute if the condition was true. Else, it's embedded in else that the condition of else is the opposite of the condition of if. So the condition of else is the opposite of the condition of if. Okay? And if the else if is true, you will only execute the body of if. If the condition is false, we will only execute the body of else. So this is what we saw in the previous lecture, that we have a flow chart. Okay, if it's true, it will go in a direction, and if it's false, it will go in the other direction. So this is the if, this would be the if body, and this would be the else body. Okay, I don't know. Okay, anyways. So this is the else here, the else body, and this is the if body. We execute one of them. So if the condition was true, we execute the if body. If the condition was false, we execute the else body. We talked about this previously. We talked about everything previously, but this is just a revision for you to understand it better. Okay? And it's like a comprehensive view of all the different if structures. So we have if else. So if else, this is an example of an if else. Please enter an integer. You input an integer here. Okay. If number, so modulus 2 is equal to 0. So we talked about modulus in class. This means that the number is even. So if this is true, printf %d is an even integer. So where's the body of f? This is the body of f. خلصت. So if it's true, I will only execute the body of f and continue here. This is very important. You don't do the else, either the if or the else. So if it was true, this will be executed. Else, which means that if this was false, which means the number is odd, only the else is executed. And as I said before, else never has a condition beside it. It only has the word else. And the condition of else is the opposite of the condition of if. So if number modulus 2 equals 0, this means that number modulus 2 is not equal to 0. Then this is going to be executed. So if the if was true, this is executed. We continue here. If it was false, we do the else and we continue here. This should be clear. Please, at any point you can repeat so that you grasp the information thoroughly. So if we execute this, we continue after. Else, if it's false, we do the else and we continue after the structure of if else. So this is if else. For example, enter an integer. It was 7. How would 7 do? Is 7 modulus 2 equals 0? No. Skip this. So for 7, so if the number here was, let's say, 7, is 7 modulus 2 equals 0? No. Skip and go to the else. Printf, the 7 is odd, and you continue. There's nothing, no statements here. That's it. So the program ends. So enter an integer 7. 7 is an odd integer, and this was the body of else. So we had if statement, if alone. We had if else statement, and here we have nested if else. What's nested if else? We're saying that very simple. This is an if. This is the body of if. So this is the body of if, which means that it will be executed whenever the condition is true. If the condition was false, I will go to the else, right? Okay. In the body of else, I have another if. So in the body of else is another if. We call this ladder if else. Okay. In a ladder if else, only one of these statements is going to be executed. If it was true, if the condition, the first, if expression 1 was true, okay, it will execute this body and go away. So one of these, let's say it looks like a ladder, okay, all right. So one of them is going to be true, and they all go to the same point. Either, yeah, so the compiler will choose one of these expressions. One of the expressions is going to be true. Okay? And at this point, they all come to the same point of the ladder here, which continues after the if-else structure. Okay? So if this condition was true, if the first one is true, you execute like this and you go down. If it was false, else, if, and this expression was true, expression 2, you would go this way. Instead of this way, you choose one of the paths and go to the next structure after the if-else nested structure. So you continue after the if-else nested structure. If this expression was true, let's say this one, you would execute this one instead, not this one, not this one, none of these, only this one, and you continue with whatever is after the if-else structure. Okay, so only one of these executions is going to be true. This is an example of an if-else ladder. Okay, so we have two numbers, two integers, number 1 and number 2. Okay, we input number 1 and number 2 here using scanf. We want to check if the two integers are equal. If number 1 is equal to number 2, okay, printf number 1 is equal to number 2. So this is the printf. That's it. You continue. You go to return 0. You don't do anything else. So that's the ladder. Else, if number 1 is greater than number 2, you do this one. Printf number 1 is greater than number 2, and you go here. If this was also false, you go to this else. Else, number 1 is less than number 2, and you go here. Okay, so you have 3 branches. One of them is going to be true. And always this else is the opposite of this condition. So this else is the opposite of the condition of number 1 equal number 2. So number 1 is not equal to number 2. There are two conditions. There are two states. Either number 1, so if number 1 is not equal to number 2, we go to the else. Not equal means they are either greater than or less than. So if number 1 is greater than number 2, we do this. Else is for the previous if. Okay, so else, this means that they are not equal and they are not greater than, so definitely they are less than, and we do this one. Okay, look at it please, you'll find it straightforward. This is an example. Let's say we enter 12 and 23. So if you have 12 here and 23 here, so 12 and 23, is 12 equal to 23? No. So what do? You go to the else. Is 12 greater than 23? No. You go to the else, which means that 12 is less than 23, and this is the output. 12 is less than 23. That's the printf, the last printf. Okay? If you don't have, there's another, that's the last one. If there's no ladder, okay, then we can have also, it's possible to have if-else statement inside the body of another if-else statement. So simple if-else statements inside each other. So this is nested if-else, the normal one, okay? So let's say we have number 1 and number 2, okay? We input them, the same example as before, but we can do it in a different way. So if number 1 is greater than or equal to number 2, okay, I go inside. Where is the body of this if? Let's check where the body of this if is. So this if, number 1 is greater than or equal. You have this is the beginning of the body, and this one is the end of the body of which if? Of this if, okay? So inside the if, number 1 is greater than or equal to number 2, I have the first option, is number 1 equal to number 2? So if number 1 is equal to number 2, I'm going to say number 1 is equal to number 2. Else, this condition was true. It's either greater than or equal. So it's either equal, so else is what? The greater than. So else, number 1 will be greater than number 2. And this else is for this if. This is inside this if. So inside this if, number 1 greater than or equal to number 2, I have two options. Either number 1 equal to number 2 or number 1 greater than number 2. Else for this if now, for the first if, because this else and this if are covered, so I still have this else, it's for this if. So else, which is the opposite of number 1 greater than number 2, or greater than or equal, which is definitely what? Less than. So I say that result number 1 is less than number 2. So you can have any structure. Always remember to enclose the body between braces, so to be more specific and not to fall into mistakes. Okay, although in this example, by the way, you can remove all the braces because they're all one sentence body. So as we said, it is possible to include an if-else statement inside the body of another if-else statement. All right, this is more that was a revision of if-else and more examples on if-else. Now the logical operators. In C programming, there are some logical operators in the and, or, and not. So this is when you have more than one condition, okay, in a certain if. Instead of doing, let's say, if you have two options, number greater than or equal 90 and number grade less than or equal 100. You have two conditions. If there are two conditions, instead of doing them as two ifs, you can do them in one if and have the conditions combined with and, or not. So if grade is greater than or equal 90 and grade is less than or equal 100, if these both conditions are true, and because I have and, so if this is true, if this condition is true and this condition is true, printf excellent. Else, which means either this or that was false, then output not excellent. So when would the else be good? When are we going to execute the else body if this condition, one of these was false? So if has two conditions, okay, in this case there's an and you have two conditions, okay, it's only true if both parts are true. If one of them is false, then we'll go to the else. This is the and. Okay. This is the truth table of the and. If expression 1 was false and expression 2 was false, then expression 1 and expression 2 is false. If 1 was false and 2 was true, then are they both correct? Because if there's an and, is expression 1 and expression 2 true? No, so that's a false. If the expression 1 was true and the second one was false, then the whole expression is false. It's on, as you can see, it's always false. So the condition is going to be false, the combined condition, always false, except when both of the conditions are true, which is what it actually means here. What it means is that expression 1 and expression 2 are true. So it's only true if both expressions are true. If one of them or two of them are false, the result is going to be false. What about the or? From its name, or, only one of the condition needs to be true. So false or false, I'm saying if this is true or this is true, or if expression 1 or expression 2. So if they're both false, definitely the answer is false. If one of them is true, then it's true, because I'm saying if expression 1 or expression 2 is true. So if one of them was true, then the or expression is true. If both are true, then definitely also is true. So the opposite of and or condition or operator, logical operator, would give me always true, except if both of them are false. That's the opposite of the and. Not expression 1. So not false is true and not true is false. By the way, there is a lecture after this, on board lecture, which you can see it after this lecture. It's about logical operators with more examples. You have to actually watch it as well, which is below this lecture. Okay? We will continue next time.